Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we're going to be talking about what reciprocals are and how we can use them to turn division problems into multiplication problems. Let's jump in by getting used to this new vocabulary term. So what is a reciprocal? A reciprocal is a reversal of any rational number except 0. And to see what this reversal looks like, we can consider some examples. So the first thing that we want to do when we're talking about reciprocals is make sure that we always express our starting value as a fraction. If we start out with a fraction, like 3/4 for example, that's no biggie. We were handed a fraction in the first place. But if we're handed a whole number, something like 6, what we need to do is turn that whole number into a fraction by putting it over a denominator of 1. Now you don't have to do this step, but it helps for visualizing the parts of the reciprocal, so I do recommend it. Once you've set up your initial value as a fraction, if it started out as an integer, to find that value's reciprocal, what we have to do is flip-flop that fraction. So what was the denominator becomes the numerator, and what was the numerator becomes the denominator. If we consider our example of 3/4 then, the reciprocal of 3/4 would be 4/3. I flip-flopped my top and bottom numbers. Similarly, if we start with 6, which we can consider 6 over 1, and take its reciprocal, we'll find a reciprocal of 1 over 6, or 1/6. Again, flip-flopping the locations of the numbers in the denominator and the numerator. Any fraction that we can express as a over b, its reciprocal is b over a. Now that we know what a reciprocal is, let's talk about some places where we can use them. Reciprocals are really handy in times when we have to complete division problems that we may not really like. That's because these reciprocals allow us to use a system that a lot of teachers will call keep, change, and flip, to turn division problems that might not be so nice into multiplication problems that are a little more accessible. Let's take a look at an example. Let's say that I had something like 7 divided by 3/4. Not only do I not know what that is, but dividing by a fraction sounds like a real headache. So here's where this keep, change, flip comes in handy. Keep tells us what to do with the first value. I'm going to keep that 7 the same. So I still have 7. Change tells us to change the operation that we're doing from division to multiplication. And then flip tells us to take the reciprocal of the value that we were dividing by and actually multiply by that reciprocal. The reciprocal of 3/4, like we talked about earlier, would be 4/3. Now I'm still dealing with a fraction here, but multiplying with a fraction is a lot nicer than dividing with one. So I'm going to rewrite this as 7 over 1 times 4 over 3, turning that 7 into a fraction so that I can multiply across top by top and bottom by bottom to get our answer of 28/3. So now I know that 7 divided by 3/4 would actually be 28/3. But we were able to work through that problem using multiplication instead of division. This is where reciprocals really come in handy. We can also see reciprocals being helpful in later algebra problems that we might complete. So you might not have seen a problem like this at this point, that's okay, but it'll make some sense later on, so I want to expose you to it. Let's say that we had something like 5/4 x equals 3. I want to get x on its own, and the way that I do that is breaking its relationship with other values. So I see that it's connected to 5/4 through multiplication. That tells me I need to break that relationship with the opposite operation. That would be division. So if I'm looking at this using the opposite operation, I would have to divide both sides by what I want to get rid of, which is 5/4. That means on the right side, I'll have to divide 3 by 5/4. That's not something I'm really interested in doing. This is another situation where instead of dividing by what we want to get rid of, we can multiply by its reciprocal, basically using part of keep, change, flip. So instead of dividing by 5/4, I can multiply on both sides by 4/5. This now becomes a much simpler problem to complete. On the left side, because I have 4 times 5 on the top, which would be 20, and 5 times 4 on the bottom, which would also be 20, I really have 20/20ths, or just 1. Of course, x is still there, and we can just write 1x as x. And on the right-hand side, we have 3/1 times 4/5. Again, I chose to turn that 3 into a fraction just so this multiplication with a fraction is a little bit easier for me to do. That tells me that on the top I'll have 3 times 4, or 12, and on the bottom I'll have 5. So, with relative ease, I found that the value of x must be 12/5. Now, do we have to turn fractions into their reciprocals and use multiplication to complete these kinds of problems? No, there are tricks that you can use to keep using division, but most students are more comfortable with multiplication, so if there's a way to turn a problem into something you feel more comfortable with, why not use it? Well, I hope this has been helpful to learn about reciprocals, what they are, how they work, and where we can use them to help make our work a bit easier. As always, if there are any other questions that you have or topics that you'd like to see discussed, please let me know down in the comments. If you enjoy our content, please like and subscribe. Thank you so much for spending part of your day with me, and I'll catch you next time.